So in this presentation, two main ideas. What are the types of occurrence data? And according to the title of my presentation, so I titled it the concentration of chemicals in food. Thank you, Dr. Mustafa. So the concentration of chemicals in food, because as we said, starting from now, our discussion is targeting chemicals and more specifically contaminants, but we will be introducing here also information about different chemicals. And then we will be tackling the different sources of concentration data. We will be speaking about how we can use maximum levels and maximum residue limits as the source of concentration data. We will be speaking about the different sources of those concentration data coming from measured or reported concentration. And we will be starting to introduce briefly the sources, the publicly available databases for those concentrations of chemicals in food. So by the end of this module of our training, hopefully we will be able to identify and select appropriate concentration data for use in estimating dietary exposure to chemicals in food. So our objective is to understand the occurrence data part. Two, differentiate between sources of concentration data, as we said, and types of concentration data. And three, to explain the role and use of publicly available databases in sourcing those concentration data. As we started to introduce, so we may access different types and we may have different sources of those concentration data. So here we're speaking about al-tarakis, the concentration of chemicals in our food. We might or we will be using different types of data, whether we are targeting chronic or acute dietary exposure. So we will give further examples. The most important thing is to start having the mindset of a consistent and standardized procedure for understanding the data, compiling the data, and submitting the data. That's our main objective, having a consistent and standardized approach. And that is one of the targets of our work. And of course, it will be crucial, and we will be discussing more these aspects, to consider the quality of our data. And the quality comes from different parameters, among which the importance of the sampling. So we will be discussing the different sampling. When we speak about a targeted sampling or a random sampling, what's the difference here? And what's the impact on our data? And of course, the different requirements and performance coming from the analytical methodology. Why? Because we need to understand the quality of our data, and we need to understand the idea that we will be merging, compiling data coming from different sources and mainly from different analytical methodologies. So before compiling this data, we have to understand whether we can gather this data coming from different sources and different analytical methodologies, and how and why. So that will be the target of a very important presentation by Dr. Eli tomorrow. Now, our concentration data. Let's, starting from now, start to differentiate and separate between two categories of chemicals in food. So we have the chemicals, as we said, which are intentionally added to our food in order to get any technological impact, like additives, like nutrients added in the situations of food fortification, for example. So we add those chemicals, and the situation of residues which remain in the food. They are not perhaps supposed to remain, but intentionally and undoubtedly, we will have certain levels of residues remaining in our food, and their application is intentional and should be consistent with good agricultural or manufacturing practices. So first, this intentionality of adding the chemical. Normally, what we use, we tend to use mean concentrations, average concentrations. So here I'm starting just by introducing the types of data that we use. So these mean concentrations, average values, will reflect average expected concentrations over time. And of course, starting from now, the majority of our discussions will be targeting chronic dietary exposure assessment. So that's the situation we will be more discussing, and that's the situation discussed in Codex proceedings and Codex committees. Normally, for those intentionally added chemicals, the major source of this information comes from the industry, from the manufacturer itself. So when we perform any assessment, we rely on concentration. So here I'm speaking about concentration information. In the situation of additives, of added nutrients, they come from the sponsor, from the manufacturer, from the industrial itself, who developed the use of this additive. They will be compiling this information, among other information for sure, in order to form a full application dossier that will be submitted to JECFA, for example, for the situation of additives, in order to evaluate. So the major source of concentration information here, then what we call in the situation of additives, for example, the maximum use level of additives, comes from the industrial itself. Now, the same situation for nutrients and the situation where we are adding more nutrients, because nutrients occur naturally in our food, but they can be added also in order to fortify the food. So here we often use mean concentration in the situation of chronic dietary exposure assessments, and we can access these average concentration from composition tables, from labeling, from the manufacturer or the industrial itself. So that's mainly the source of this information. They are declared because they are intentionally added. For the situation of residues, so here we target mainly two types of residues, always pesticide residues and vet drug residues, right? So in the situation of residues, we tend to use median. I will not dive now statistically in why we use median versus mean, because we will have a separate presentation for that. But just to let you know at this level that for the situation of residues, for example, we use what we call supervised trials median residue levels or concentrations for the case of pesticides. And we use the median residues for the case of depletion studies, what we call depletion studies, which are implemented or applied for the case of vet drugs residues. Okay, so from where, what is the source of data? The type of data used here is normally median, excuse me, we can still have average data used. And the source comes from, for the case of pesticide residues, what we call field trials, right? When we are testing the pesticides, we apply field trials at what we call good agricultural practices. And then we do analyze the residues remaining in our crops. So the main source of this concentration, this occurrence data, comes from the field trials. For the situation of vet drugs, those occurrence or concentration data comes from what we call here depletion studies. So we give the drug to our animal, then we follow up over time the depletion of this chemical into a targeted tissue, let's say in the liver, in the muscle, in the kidney, etc. So that's the source here in the case of residues. And now the situation of contaminants, right? So now when we speak about contaminants, we are speaking about unintentionally occurring chemical into our food. So we're not discussing here why it's occurring. So normally for this situation of contamination, we tend to use average concentrations in order to perform the calculations. Why? Because they give a good representation for chronic situations. These mean concentrations, normally they come from monitoring or surveillance data or plans implemented. I'm not detailing more where we use median or mean, but just to tell you that median could be a better statistical representation of the occurrence data. And we will be discussing that more from statistical perspective. And that was the question. The mean, is it always a better measure of central tendency than the median when evaluating concentration data for dietary exposure? So I already answered this question. So in a lot of situations, we have, for now, I will just tell you that we have to pay attention which value to consider, the median or the mean or different types of mean, of averages that we can have. So it's very important to understand that. It's not like automatically I will be averaging my data distribution and consider the mean and do my calculations. No. Now, the different sources, as we said, we can have different sources of those occurrence data. As presented by Professor Sam, by Dr. Karima, why not use maximum levels or maximum residue limits in a lot of situations? We're not supposed every time to access real generated new data coming from, let's say, a monitoring and surveillance plan or total diet studies. In a lot of different scenarios, we can just go and use the maximum levels, which are implemented at our national level or which we can source from international databases, the Codex Alimentarius or others. And not diving too much now in the different scenarios, we will be discussing that, but just to let you know that MLs and maximum residue limits can be used as the occurrence data. And Dr. Karima gave some tips here. They can be a good representation of a worst case scenario. Let's say we suppose that we have a very good implementation and enforcement of our regulatory provision at the national level, okay? باعتبار إنه we are implementing this maximum level. So normally in an ideal situation, when we sample a food commodity and we do analyze for this contaminant, بالمبدأ, normally we should not have concentration above a maximum level, right? Otherwise, this food should not be commercialized. So in a lot of different scenarios, and taking this assumption, I can use the maximum level itself as being the worst case scenario for the occurrence of this contaminant in my food. Let's say I don't have access to monitoring data. So why not having this maximum level value taken into consideration and performing some calculations? So we can use MLs and maximum residue limits. And now, ideally, I should be able to access measured or reported concentrations, right? Coming from, for the case of pesticide residues, coming from supervised trials, as we said. So again, what are the supervised field trials? They are trials designed to determine the maximum residue concentration that may be present in the harvested product at the earliest point at which these commodities could enter commerce as food or feed for animals, and taking into consideration the good agricultural practices. That's the definition of it. But are we let's say we are doing some dietary exposure calculations for chronic situations, okay? Or for acute situations. I will not be using the same representation for my occurrence data. If I'm considering chronic exposures, I will be using the median, for example. Why? Because normally field trials, we don't have a lot of data points when we do field trials. We are limited. Our data set is limited because they are field trials. We cannot generate a lot of data points. So we use median. But let's say we want to do some acute exposures. We will be using the maximum residue occurred, the maximum residue occurrence concentration after those field trials. So you can see the difference here between acute scenarios and chronic scenarios. So for the chronic scenarios, I will go for a median, for a mean value. However, if I'm targeting some acute situations, I will go for the maximum residue level occurring after my field trials. So same for the vet drug residue situation, but here we call them depletion studies, as I said. So they are designed to estimate the formation and depletion of residue, which can be a metabolite, which can be a residue, a certain kind of residue to my initial vet drug I administered to my animal, as the marker in normally edible tissues. So normally we have to target some edible tissues in the animal. But in other situations, we target some marker tissues, which are not particularly consumed in certain situations. So we have to pay attention on which data we are using. Again, always with the case of measured or reported concentration. Now, of course, one of the ideal situation is to access data coming from monitoring or surveillance programs. Considering the limitations, we will be discussing some limitations, but just to tell you that here, they are good quality of data for exposure assessments, collected close to the point of consumption. They are somehow more representative than early stage commodity sampling, as the situations we explained. However, we will be discussing some limitations and some bias coming with data coming from a monitoring and surveillance program, because when we implement a monitoring and surveillance program, normally it is for compliance verification. So we have to consider this bias, and we will be discussing that further in upcoming presentations. One very important information, the type of sampling that was implemented. And briefly, we have different types of sampling. When we speak about sampling, we have the notion of what we call sampling plans, right? It's a full statistical knowledge and competency related to the sampling plan situation. But just here mentioning two types that are usually applied in the case of monitoring and surveillance programs, which are the targeted sampling and the random sampling. Just saying, without diving here too much into the statistical definitions of both, but just saying, if I ask you the question, if I'm considering a targeted sampling approach, meaning I will go and I will sample with the full previous information and decision, what is the exact sample I will be taking? That's my targeted situation. Or I'm going and I'm sampling considering the statistical definition of random. Okay? Which data coming from which type of sampling is better suitable for the situation of a chronic dietary exposure assessments? What do you think? Coming from a targeted sampling, I'm going and I'm sampling this particular commodity for this particular contaminant because I had this particular situation, or no, I have like I'm doing a certain screening for a particular contaminant, let's say, and taking samples in a random way. Which one is more suitable? The random approach, okay? So of course you have the why. Now, again, as we said, for pesticide residues and for vet drug residues, we will have maximum residue limits. We will have data coming from field trials and depletion studies, but also we can access data coming from monitoring and surveillance programs for the situation. So all this kind of data can be used in order to represent this category of chemicals. Some limitations when we speak about monitoring and surveillance data. If we speak about the methodological, analytical limitations, monitoring is often designed by itself for compliance, okay, for compliance verification. So we will be selecting an analytical methodology which will be able to answer the question of compliance. I will not go for, let's say, more sensitive or more accurate analytical methodology. If I'm just verifying for a compliance, let's say, regarding a certain contaminant having a maximum level in the ppm range, let's say 1 milligram per kilogram or 2 milligram per kilogram or 5 milligram per kilogram, why to go and perform the analysis using an analytical technique which has LODs and LOQs in the ppb range? Do I need them? Normally, no. I will not go and have further sample preparation just for the sake of having more sensitive analytical methodologies. Because here, my main objective is to verify for the compliance according to a standard, to a certain provision, right? So that's a limitation here. My result is biased, starting from here, biased by the performance of the selected analytical methodology. Okay, do we agree? So in other situations, perhaps I will be interested in having lower sensitivities, lower LODs and LOQs. So that's the first level of limitation or bias. In the case of depletion studies for vet drugs, in some situations, they will be very tissue-specific residue occurrences. Perhaps I'm interested in having the occurrence of my vet drug residue in other tissues. Of course, I might have different scenarios and methodologies in order to convert, let's say, a certain residue concentration from a tissue to another tissue, etc. But that will introduce more uncertainty. So that's a limitation in the case of occurrence data coming from those studies. Data gaps and representativeness, that's also a bias here. So monitoring covers only a small fraction of the food supply. And from here, from this limitation, we will understand more the advantages of a total diet study, okay? And the occurrence data coming from a total diet study. So for saying that here, in some situation, they cover small fraction of the food supply. They may miss other residue values affecting acute exposure estimates because we're not interested in those occurrence data. Sampling, as we said, might have a certain targeting information, which is not very well in line with the good representativeness that we're searching for. So a lot of uncertainties should be considered, considering all these different situations of that. The answer, the ideal answer, is to have a total diet study implemented and to have occurrence data coming from a total diet study. So the total diet study will be answering all these limitations. Yes. No worries. So I still have what, 2 slides. Okay, so a total diet study, not diving too much into details. Professor Samuel gave us some information, but just for us to know, here comparing the different qualities of data coming from different sources and the affiliated uncertainties with them. So when we have a total diet study, this is a complementary approach to traditional monitoring and surveillance programs. Through a total diet study, we will be measuring the chemical concentration in food as consumed. So we are removing this bias. Okay. Why? Because in a lot of situations, the fact of preparing the food, handling the food could change the occurrence, the concentration level. It's not a big issue because when I'm taking monitoring and surveillance program, I'm in a worst case scenario. That's not an issue. But if I'm aiming to have less uncertainties and more accurate representation of the real situation, analyzing the food as consumed should be the ideal situation, right? It will reflect also real life food preparation. In some instances, I'm peeling the food. In other instances, I'm cleaning, washing the food. I'm cooking the food. Okay? I'm removing some parts of the food and leaving other parts which are consumed. Perhaps in other situation, no. I will just be homogenizing the food commodity and analyzing it as it is. Let's say mixing the liquid with the solid part of a can, but in a real life situation, I will be removing the liquid part and consuming just the solid part of the can. So I will be reflecting all of that in a total diet study. I will have a kitchen and I will be preparing my food before analyzing the food. It will account for loss of unstable chemicals and formation of new compounds during preparation. So this situation, this level of accurate occurrence data can only be accessible through a total diet study situation. Provides accurate average concentration of pesticide residues, contaminants, nutrient, other food chemicals, the bias related to the analytical methodology. So in the situation of total diet study, I'm not aiming a compliance verification. That's very important. What I'm aiming is to have the most sensitive and accurate analytical methodology covering all hazards that I identified, I prioritized. So the idea is not to compare the level of I'm getting to a provision in order to say it's compliant or not. The idea is starts by defining well my situation, prioritizing what I'm targeting, and then having the most accurate analytical methodology in order to get the most accurate occurrence data, okay? So in this situation, if I say my contaminant is not detected, I'm sure I'm saying not detected comparing to a very low limit of detection. It's not, I'm not saying it's not detected in a compliance situation and my limit of detection is 0.5 ppm. Okay, so if I'm saying here not detected, I'm saying not detected with an LOD of 10 ppb. Okay, so I'm minimizing the uncertainty coming with the fact that I'm saying non-detected or detected. That's just an example. Best suited for chronic dietary exposure, as Professor Sam said, because it's continuous. Normally, when we have a total diet study implemented, it is always continuously updated and implemented. It's not like limited to a monitoring and surveillance program scenario. It is, yes, not suitable for acute exposure because we're averaging, okay? Here we are averaging, we have composite samples that are analyzed. So the information by itself is an average information, not suitable for an acute exposure, but it's very suitable for chronic dietary exposures that we will be discussing. Okay, so that was our introduction for the different sources and types of data. And I tried to organize the information of occurrence data according to the most ideal situation. But can't we use any kind of data accessible? So let's keep in mind that any kind or type of occurrence data available, we can still use it, knowing and accounting for the limitation and expressing those limitations in a very transparent way. But we're not allowed, starting from today and our workshop, we will not allow someone telling us that we don't have data, okay? Or we cannot access data. So of course you have data, of course you can access data. The most important thing is to understand the data we can access. So just briefly, the last slides, when we spoke about MLs and maximum residue limits, from where we can get them? We can get them from a lot of databases. So starting with the Codex databases, right? So we have online databases, and hopefully we will have the online Codex database related to contaminants, which we don't have till now. So for contaminants, we have to go to the text of the standard. But for pesticides, for vet drugs, and for the additives, the GSFA, we have online databases. We have our famous GEMS food database that we will tackle after the lunch. Very important source of information, accessible for everyone. And hopefully you have some national or regional databases. Otherwise, that's our main target with you after this workshop, to help you implement your national occurrence databases. And of course, also all the part related to the food part, the nutrients databases, the food compositional databases. So that's our target. We aim to have this level of databases and information at the national level. So finishing with this question, and we also reply to this question. So why are total diet studies data generally considered superior to routine monitoring or surveillance data for dietary exposure assessment? So which option do you think? A, because they include only raw agricultural product? No, we said total diet study is the food as consumed. B, they reflect actual consumption levels in food as prepared and consumed? Yes. They are collected more frequently than monitoring data? No, they are not collected more frequently. They focus only on contaminants in imported foods? That's not the situation, okay? So here, just to show you the limitations with the monitoring and surveillance situation and the total diet study. So that's it. That's the first introductory presentation related to occurrence. It's very important to manage our data. The data plays a key role. I will not be repeating everything said by Professor Sam and Dr. Kalima related to the importance of having our data, our occurrence data. And understanding our data. Okay, so again, our main target is to understand the data and know how to handle this data.